Okay, here we go, our last unit. I'm going to eat some cashews while I'm doing this video. So, our last unit, Unit 11, Lesson 1. Yay! Intro to Systems and Graphing Systems of Equations. So here's our learning targets. We're going to be able to solve systems graphically. That's what we're going to talk about today. And let's get some definitions out of the way. So, a system of two linear, we're going to be back to linear equations. So, system of two linear equations and two variables x and y, also called a linear system, consists of two equations that can be written in the following form. Remember our linear system, ax plus by equals c. And if we had another equation, we just name the variables dx, d and e and f. So that's two different equations. A solution. A solution to a system of linear equations is an ordered pair xy that satisfies each equation. Each equation. So we want to tell whether this ordered pair is a solution to the linear system. Here's our linear system. We want to say what this ordered pair is. Remember, this ordered pair is an x and a y, right? So what we do is we plug them in into this equation. I'm going to plug in the 3 for x, 3 plus 2 times y, but y is going to be 3 equals 9. Well, it's 3 plus 2 times 3 is 6 equals 9. I get 9 equals 9. That works. But it has to satisfy each equation, so I need to check it in this bottom one also. So the bottom one I'm going to check right down here. So 4 times 3 minus 3. I plug the x and the y in. 3 and 3 for x and y equals 15. 4 times 3 is 12 minus 3 equals 15. So what's 12 minus 3? I'm going to put it right up here. Sorry, we ran out of room. I get 9 equals 15. Does 9 equal 15? No. So is this a solution? No. If this would have said 15 equals 15, it would have been a solution. But 3 is not a solution to this linear system. Okay? Because it has to satisfy each equation. Okay? One way you can solve a linear system is by graphing. Here now we're going to learn how to graph, but we're going to use this system, this idea to check. So, a solution corresponds to a point where the graphs of the equations intersect. So here's 3 different ways we're going to be showing things graphically. We have exactly one solution in a linear system. You're going to get 2 lines and they're going to intersect at one point. That's the solution right there. Lines intersect at one point. We're not so worried about consistent and independent, but just that is one solution. Okay? Infinitely many solutions, or IMS. What that means is there's one line and then another line lies right on top of it. Okay? Lines coincide, same line. So another line lies, that's infinitely many. All these points along here, all are solutions. Okay? And then there's no solutions. When you graph a line and another line is parallel. Parallel meaning it's never going to touch. If it wasn't parallel, it would touch. Okay? But if it's parallel, it's no solution. They never intersect. No solutions, lines are parallels. Okay? Now how can we explain this if we need to explain this? If lines have 2 different slopes and different y-intercepts, there is one solution. So where's our one solution? Right here. 2 different slopes. This has a slope, and if it has a different slope, it's going to cross that line at one point. It has different y-intercepts also. So different slope and different y-intercepts. That means there's going to be one solution. Okay, so if 2 lines have the same slope but different y-intercepts, so which one would have the same slope? Looks like that line and that line. This one lies on top. It has the same slope, but different y-intercepts would be this one, so there's different y-intercepts. Well, there's no solution. Same slope, which means they're parallel, and different y-intercepts. Okay, if you think of these graphically, picture-wise, maybe that helps. So if 2 lines have the same slope and the same y-intercepts, just like this one. Here's a line, and then I graph another line with the same slope right on top of it. It's got one y-intercept, so that means there are infinitely many solutions to the system. Okay, solutions to a system on the graph are where the two functions intersect. So where they intersect, we're going to get an ordered pair. So this is graphically. So a line can also intersect with another function, such as a quadratic function. We know about quadratics. So how does that happen? Well, up top here, we have this system here with two solutions. So I got a line, and it crosses a parabola. Two solutions. I have a line and a parabola, and it just crosses at the vertex. So touches, one solution. Parabola and a line, it never touches. This keeps going this way, this goes way up, it'll never touch, no solutions. So where it intersects, that's a solution. We could get that ordered pair, and that's a solution to that system. That's a linear system with a quadratic system, with a quadratic function. Linear function and quadratic function. So it says use the graph to estimate the solutions to the system. Make sure to say all the solutions if there's more than one. Make sure to write your solutions as an ordered pair. So what do we think? How many solutions are here? Well, it crosses one time, so there's going to be one solution. And where does that cross at? It looks like it's going to be 2, 0. Ordered pair, 2, 0. That's my solution. Right there, that is 2, 0. Okay, what about this one? A line and a parabola. Crosses two times. 1, 2. There's going to be two solutions. Okay? What are those solutions going to be? Let's check them out. That ordered pair looks like it's going to be what? -2, 4. -2, 4. And the other one looks like it's going to be 1, 1. So right where this line crosses that parabola, that's a solution, 1, 1. And there's another solution. So two solutions on that one. Okay. Have some more cashews. So, student said there was one solution to the following system. Explain why he is correct or incorrect. Well, if I saw this, I got a line crossing a parabola at two different spots. I know that's two solutions. So, how do we say this? So, the student is incorrect because the line intersects the parabola in two spots. So there are two solutions. So he was wrong. Two solutions. If it only crossed, if it had a picture here and it crossed one time, we would say he was correct because it crossed one time if that was down here. Okay? So graphically we can solve these systems. We just look where the intersection is. That's the solutions. There's two solutions there. Alright, getting to the end of the video here. So, example 4. Solve the system by graphing. You may need to write in slope-intercept form first. What's slope-intercept form? Y equals mx plus b. See, it comes back. We got to know this stuff. Then we're going to check our solution. Important. So, how do I graph lines? Do you remember how to do this? We got to think way back. what's my slope here for this first equation? I need an m and a b. The b is the y-intercept, remember? So the b is 6 and the slope is -1. So I go to 6. 1, 2, 3, 4. Here's 6. And now a -1 slope means down 1 over 1. Down 1 over 1. Down 1 over 1. Okay? And how are we going to graph that? We're going to take a ruler. There's a line. It goes this way. Goes on that way. This one over here. I need an M and a B. So my B is -2. That's the y-intercept. The M is going to be 1. So I go to -2. I plot the y-intercept. And a positive 1 means up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Okay, that's enough points to plot. We draw our line, put an arrow on it. Okay, what does that point look like? That point looks to me like it's 4, 2. So 4, 2. But when we graph, maybe it's a little off, so we want to check this. How do we check? Well, just like we did in the first couple examples, we're going to plug it in. So I check 4, 2, and y equals -x plus 6. And I'm going to check 4, 2. So 2 equals a -4 plus 6. X and y. So 2 equals -4 plus 6 is 2. That checks. I have to check it in the other one though. Y equals, x minus 2. So I get 2 for y equals x, but I'm going to plug 4 in. So 4 minus 2 is 2. Does 2 equal 2? It checks. Solution checks. It's a good solution. Okay? Now, if we graph those lines, and if we got something that looked like on the first page, they were parallel lines, well, there'd be no solution. Okay? Or if we graph the line, and then we graph the same line on top of a multiple of that line, had the same slope, same y-intercept, infinitely many solutions. So keep that in mind when you're doing the U-tries. Keep this in mind, important. Okay? All right, last question. Describe what the graph of the system of linear equations will look like in the standard xy coordinate plane for the following. You may use your calculator to graph. So we could graph these, but how do we have to graph those? Well, to graph them, we have to solve for y, if you remember. So this first one I'm going to take over here. I'm just going to rewrite this. 4x minus 3y equals 8. And what do I need to do to solve for y? I'm going to subtract 4x from both sides. I get -3y equals a -4x plus 8. We're going to keep the x in that spot. I'm going to divide by -3. Divide by -3. I get y equals, well, -4 divided by -3 is just a positive 4/3 x. And this is minus 8 over 3. I'm just going to break it into two different parts. So now I know my slope is going to be 4/3 and my y-intercept is -8/3. That's going to be important. We need to know that. So now we're going to take a look at this one. 8x minus 6y equals 16. Solve for y. We want to solve for y. Get it by itself. Subtract 8x. Subtract 8x. -6y equals -8x plus 16. I'm going to divide by -6. Okay? So this gives me y. I divide this -6 into each piece. So I get 8 over 6x minus 16 over 6. I can simplify that a little more. 8 over 6 is really 4 over 3x. 16 over 6 I can reduce, minus 8 over 3. So my slope here is 4/3. My y-intercept is -8/3. Well, We could go and graph this. Okay? We could use the calculator. If we use the calculator, we're going to see this is the same line. Look, its slope is 4/3. This slope is 4/3. Y-intercept is -8/3. -8/3. It's going to look like this right here. We're going to put a line, and then another line is going to lie right on top of it. So this, we're going to describe it. It's going to be two lines that, if you want to say coincide or lie on top of each other, okay, and infinitely many solutions. Okay, so describe what the graph of the linear system looks like. Well, it's two lines that lie on top of each other because they have the same slope and the same y-intercept. Maybe we want to talk about that also. Okay, so a lot I said, didn't write down, but you want to talk about same slope, same y-intercept. Same slope, same y-intercept. That means it's the same line. So after watching this video, fill in what you can do, what you can't do. Definitely try the U-tries, and we're going to go over those tomorrow. See you tomorrow.